Hello, good evening, everybody. Welcome to another episode of Physics with Papa Lim. Okay, now in this classroom today, we will be looking at a short quiz or assessment. Quiz or assessment is a 35-mark assessment. Okay, on forces, moments, and mass weight density. Okay, these three topics is a paper targeted at my normal acad students. So if you are doing this paper, okay, if you are only interested in, let's say, section B or some of the structural questions, okay, feel free to just forward to that particular section, okay, because it will be a slightly longer video as compared to the normal videos that I upload, okay. So if you just need a certain section, okay, remember to just scroll through to that necessary timing, okay. You don't need to read through or watch the whole video one, okay. Now, without delaying, okay, I will start the paper now. All right, let me take a look. Where is it now? Okay, we'll be looking at the section 1, the MCQ section. Okay, the answer for the MCQ is at the bottom here that you see on the screen. Okay, if you need the answer, okay, you might want to pause the video and mark or record down the answer. Okay, now for question 1, okay, question 1 I would say is a simple thing. Okay, question 1, effect of forces. Okay, effect of forces, generally we will look at, maybe it's like we always remind students, when you look at the effect of forces, when force is applied, okay, we are generally looking at the object, maybe changing his speed, changing his getting slower, or it might be even reducing the speed. So that definitely there will be acceleration when the force is applied. Even if I reduce the acceleration to 0, so that is also a change. Okay, shapes, as we all know, okay, it gets squashed, flattened, etc. If I have acceleration, I definitely have velocity. So the one that we have, the one that we usually ask students to choose is whenever we exert the force, when what cannot be changed, okay, the mass of the object cannot be changed. So this is one of the options that we chose, okay, that we want students to know, okay, the effect of forces. Now, three forces acting on a particular object, okay, like what question 2 has said, okay, there are two forces. Paying attention, okay, to the forces, direction of the forces. Okay, I have actually two forces that is pointing to the left. Okay, so it's actually 7 Newton and 5 Newton. Now, these two forces, so pointing to the left, I will have two forces, which is 7 Newton plus 5 Newton, which is a total of 12 Newton. Okay, which is pointing to the left. And forces pointing to the right, I will have 20 Newton. Okay, which is here. Now, 20 Newton to the right and 12 Newton on the left. So the net force I'm looking at, okay, is actually the sum of forces, which is on the right, okay, and the sum of forces on the left, okay. And because both are opposite direction, let's say if I take the right side as positive, so the left side will be a negative because it's pointing in the opposite direction. So if you look at the magnitude, the mathematics will be right side with 20 Newton, left side is 12 Newton. Okay, the resultant force I'm looking at is actually 8 Newton. Okay. Okay, so that's why I even know the resultant force acting on the object is actually 8 Newton. Common mistake I look at, if you, for this question, is usually the first mistake, okay, whereby the direction. Because students always equate forces on the right side is always in the same direction. So they actually thought that 20 and 5 Newton is actually in the same direction. So it's a small careless mistake. Just be alert. Okay. Now for question 3. Okay, question 3, I will have slightly different variation to question 2. Instead of 3 forces, I have actually a number of forces acting on the system, on the object. Okay, and the object, given the question says the object doesn't move. Doesn't move. So the clue behind this particular statement, doesn't move, it means that the object is actually going at, not moving at all. So the speed is actually 0 meter per second, which also tell us one thing, the object is actually not accelerating. Okay, so the acceleration is also 0 meter per second square, which give us one important clue that relating to Newton's law, which means that because A is 0, it will tell us that the net force experienced by the object is actually 0. Okay, so this is the common linkage that we always tell students that the marker may want to illustrate. So when we talk about zero resultant, when we talk about 0, it actually have a certain implication or certain linkage, or what we call common linkage. Okay, whereby the acceleration is 0, it will imply that net force is also 0. Okay, so once you are at this level, you actually know the answer to this question already, whereby the question actually says that the resultant force is 0. Okay, so be it whether the forces are large or small, whether the forces are same size or not, it actually we can't deduce. Okay, we can't deduce from the questions. There's not enough information. But one thing I know is, regardless of the size, regardless of the direction of the force, I do know that because the acceleration of the object is 0 meter per second square, I will 100% know that the net force or the resultant force acting on an object is confirmed 0. Okay, that's why I will choose. That's why I would say option D is a better option. Now for question 4, I would say the clue that the question is telling you is that there is a friction on the object. Okay, and the object is actually going at a constant acceleration. So which means that even though the question shows there is one force P, there's actually another force that's acting on the object, which is given by the friction, which is in opposite direction, which is here. Okay, remember where to draw the friction. Okay, it's between the surfaces. You have to draw at the exact location. Okay, between the surfaces. And we also know that the constant acceleration. So if you look at it, these two information will actually give us an equation based on Newton's law. Okay, whether is it useful or not, I'm not sure, but I do know that it allows me to give to form an equation whereby it's P minus friction equal to MA. Okay, whether useful or not, I'm not too sure, but I do know that given the information, I can actually derive at the equation here. Now, based on the question, which row shows the direction and size of the F? Okay. Now, here what we know is that based on the question, I will know friction is going to the left, so you will leave me with option B and option D. So A is wrong, C is wrong. Okay, and based on the question, I will say that based on the information, okay, based on the information, I can narrow down to B and D. And what I need now is actually to look at the clues given to me. Okay, so now based on the question is that there is a constant acceleration. So what does constant acceleration means? Okay, acceleration, okay, it will mean that A will be a positive number. It has to be a positive value because we are looking at acceleration. Acceleration implies A is more than 0, definitely. So for A to be more than 0, or to be exact, for the right side to be more than 0, it will mean that the left side will be a positive number. So the sum of forces here should be a positive number, meaning that P must be bigger than F. Okay, to get a positive number. Example, P could be 4 Newton, friction could be maybe 3 Newton. So I will get a net force of 1 Newton. Okay, so I will know that P and F, the relationship between P and F is actually such that P is definitely bigger than friction. Okay, so with this in mind, I will be able to narrow down my answer to say to D. Okay, whereby P and F, the relationship between them is actually P is always bigger than F, or in other words, F is always smaller than P. So that's why for question 4, the option is D. Question 5 is a straightforward question. Students shouldn't be making any mistake for this. It's just a formula that you should know. Okay, pressure is definitely force over area. Okay, so on option is B straight away. Now, same thing. Okay, when question 6, when I squeeze the pin, okay, when I squeeze the thumbtack and thumbtack pin poke my thumb, which of the statement is actually correct? Okay, now when we look at the statement here, okay, you'll find that when I exert the force, I can actually safely say that when I push against the surfaces here, okay, when the force is applied at the thumbtack, okay, head of the thumbtack or the pin head, okay, versus the pin tip, okay, which is here, the pin tip. Okay, I will be able to conclude that the area at the head is definitely much bigger than the area at the pin head here. Okay, so if I apply on the forces, if I apply a force on the pin head, let's say I give a standard assumption, okay, I will make an assumption whereby the forces are the same. So I'll find that at the pin head, okay, versus, sorry, wrong color. So this is pin head. Okay, and I will say this is the pin tip. Okay, the red color one. If I apply the same force to both of them, okay, but the area of the pin tip is actually smaller than the area at the pin head. Okay, so if I take the ratio of them, okay, if I take the ratio of them, I will be able to derive an answer to say that the pressure at the head is actually much larger than the pressure at the tip. Okay, so because of difference in area, the pressure exerted at two different locations is actually different. And with this, I can actually narrow down on my answer to say that the pressure, sorry, my mistake, blur me. Okay, so let me repeat this. So sorry about it. Okay, because the denominator is different, because the area at the tip is actually much smaller, the area at the head is actually much bigger. So if I take the ratio between them, I will be able to derive an answer to say that the pin tip, the pressure at the pin tip will actually be much bigger than the pressure at the pin head. Okay, because why? The denominator for the pin head is actually bigger. The denominator at the pin tip is actually smaller. So the fraction or the ratio of the number, the pin tip will have a bigger number. So that's why I will be able to conclude that the pressure at the tip is actually much larger than the pin head, which is at the finger side. Okay. Excuse me. Now, question 7. Okay, question 7, I would say is a standard, is a simple manipulation of calculations. Okay, the formula that students need to know is you always remember pressure is force over area. Okay, the respective force is given in the question. Okay, and the respective area is also given in the question. Okay, so just by putting the number into the formula, okay, putting the number into the formula, area, okay, then after that put a number into the formula, you should be able to derive which is larger, which is bigger already. I would say it's a straightforward question. Okay, the only thing I require the students to know is actually to remember the formula. Okay, number 8 also, I would say is a pure regurgitation question. Okay, which are the factors affects inertia? I would say that inertia, the main factor that affects inertia is definitely have to be mass. Okay, so option is B straight away. Let me use a smaller highlighter. Okay, here you go. Now, question 9. Question 9 is a slightly, I would not say it's difficult, but I would definitely require the students to know the formula whereby weight is controlled by mass and gravitational field strength. Okay, mg to be short. Okay, so I would say on Earth, the mass, the balance of the show that the object is 2 kg and the weight is 20 Newton. Okay, so with this information, I will know that on Earth, okay, the weight of the object is 20 Newton. The mass of the object is 2 kg. I will definitely be able to find out what is the gravitational field strength on Earth. Okay, so if you do a simple math, it will be gravitational field strength will be 20 divided by 2. It will be 10 Newton per kg. Okay, straightforward. Now, what happened now is if I bring the object to the moon now, okay, what happened to the moon? What happened to the weight and object on the mass on the moon? Now, one of the things that I need students to know is that at this moment, okay, students need to know what do we mean by mass. Okay, mass loosely defined is considered the amount of matter in the object. So if the object, the cube is or the box is still the same shape, same size, nothing has changed, same amount of atoms, Okay, I never chop it off. I never drop anything. Okay, if the same object is on Earth is brought to the moon, the amount of matter in the object is actually the same. So I can actually safely conclude that whether it's on Earth or moon. Okay, oops, sorry, spelling mistake. Okay, on moon, okay, the mass, okay, on both sides must remain the same, which is 2 kg, because the number of matter is actually remaining the same. So the mass is actually 2 kg. So with this in mind, I can actually narrow down my answer. Okay, so mass, I will choose the same, so only C and D only. Okay, then next thing I need students to know is definitely, most students are required to know the gravitational field strength on Earth is 10 Newton per kg. We do not require the students to know the gravitational field strength on Moon, 1.6 Newton per kg. We do not need them to know. But we definitely need students to know the magnitude, the size. Okay, so example, gravitational field strength on Earth and gravitational field strength on Moon. Students need not know the exact number for Moon, but we definitely need to know that students need to know that the gravitational field strength on Moon is definitely much smaller than the gravitational field strength on Earth. Okay, and because of the small value on Earth, small value on Moon, the weight of the object will definitely be smaller. Okay, the weight of the object on Moon will definitely be smaller than the weight of the object on Earth because of the gravitational field strength. The G is definitely different. So the G now is a deciding factor for the magnitude of the weight itself. Okay, so smaller gravitational field strength means smaller weight. Okay, so that's why we can able to conclude that answer is actually C. Okay, now important so far until now is that I need students to know that the answer actually is not important. It's actually how I derive an answer, the thinking process behind the question. What are the clues and what are the thinking ideas that the student need to adopt? Okay, what the thinking hat the student need to adopt when they are looking at the MCQ question. Okay, with the correct thinking process, you will definitely get the answer straight away. Okay. Now, density question 10 is, I would say, quite easy. Okay, the important thing is the lightest one will actually be the one that floating. Okay, the floating means you definitely have the least density. Okay, and likewise, okay, sinking one we have the one with the highest density. Okay, it's quite I would say it's a low level question. Okay, moments. Okay, which of the object will rotate? Okay, definitely. Okay, before you talk about rotation, okay, 2 equal force. Okay, there's a clue that's given to the question. So 2 equal force, and when we talk about rotations, okay, things I need students to take note is rotation. We look at moment, force times distance. Okay, so take note the forces is actually the same. Okay, so the F is actually the same value. So now we look at the question. Okay, so if for question A, same forces, I would say the same distance for them. Okay, the same perpendicular distance. Okay, so this force, the left side force will have a clockwise moment. The right side force will have anti-clockwise moment. Okay, so since they are same force, same distance, same force, same distance, the moment will be the same, which means the clockwise will be equal to anti-clockwise, which means the option A, the rod will not rotate at all. Okay, so after that, question B, same thing. Force on the left, okay, it's giving a clockwise rotation. Okay, give me wrong color. Clockwise rotation. Okay, force on the right, in case pulling downwards, is giving you a clockwise direction also. So in this case, for option B, you will find that both options are actually, both of the forces or both of the moments are actually in the same direction. So clockwise and clockwise. Okay, so you have two clockwise moments. So definitely there isn't any anti-clockwise moment in the system here. So definitely option B, this permutation of forces or this arrangement of forces will definitely cause the beam, okay, to rotate, or the rod to rotate. So that's why my answer is B straight away, okay, without any doubt. Okay, likewise, if you are not convinced, okay, feel free to go look at question option C and option D to look at what are the moments acting on the object. For example, for option C, the top force, okay, will have a clockwise moment. the bottom force will have an anti-clockwise moment, and same as option A. And since both of them have the same force, both of them have the same perpendicular distance, the moment will be the same. And since both of the moments are opposite in directions, the moments will be cancelled out, and as a result, the rod will actually remains at the same position. It will not rotate at all. Okay, so question 11 done, and question 12, moments of forces. I would say this is quite easy. I would say like at Sec 1 and Sec 2 or grade 7 and 8, okay, you actually come across this question, so I will not illustrate much further. Now we look at section B. Section B is a structure question, short structure questions. So same thing, you need to get ready to sieve out the clues that's in the question. Okay, so that you know what are the formulas or what are explanations that's needed. Now, first thing first, okay, mass is 40 kg. Like I always tell students, whenever I give you mass, always have the habit to check that it is actually in kg, SI unit. Because in physics, most of the formula that we use at O level, I will require the students to actually input the values, that value to be in their own SI units. For example, mass has to be in kg. So if I happen to give you grams, you have to change it to kg. Likewise, speed, if I give you kilometer per hour, you have to convert it yourself, okay, to meter per second, SI unit. Okay, so based on the question, there's a 40 kg mass, and 40 kg mass, I always tell students, the moment I give you 40 kg, you must be alert, you must be ready to know that there is actually a weight here. So the weight is actually mg, which is actually 40 times 10, which is 400 Newton. So you must be alert. So whenever I give you mass, okay, most likely I will need you to convert it to Newton. So you must know. And a pushing force of 60 Newton, or another force on the ground, and there is a frictional force of 20 Newton. Frictional force imply where? Is always between the surfaces. Okay, so if I need to draw the forces, okay, you need to draw at the correct location. Now let's look at what the questions require me to do. Now, question A, on the diagram above, okay, draw and label the forces. All right, what forces am I supposed to label? Is given here, all the 4 forces. It's quite straightforward. Okay, forward force is 60 Newton. Okay, seems like skiing, so I definitely be going to the left side. Okay, so this is my forward force, my pushing force. Then after that, I have a friction. Friction, always remember, is always between the surface. So the surface is here, going backward. So this will be the friction. Okay. Then after that, I will have a weight. Remember, weight is 400 Newton. Weight is always, sorry, it has to be this color. Weight has to be pointing downward. So pointing downwards, okay, which is the weight. Then, of course, I will have my normal reaction force. Okay, normal reaction force is because my feet is touching the floor. So the floor will actually have a force that is pushing up the surface here. Okay, I would say this is the reaction force, normal. Now, so once you have all these forces, most likely your question is settled. You solve your question. Now, thing to take note when you draw these forces. At this level, try to draw, you must remember all the forces actually has one common thing among them, okay, except friction. Friction is always drawn between the surfaces. But if you look at the pushing force, the applied force, reaction force, and the weight, they're always having things in common. That's that all the forces actually act through a point. This point, what we have a name for it, is called the center of gravity. Okay, so students, you have to remember when you draw the forces, don't just anyhow draw your forces like up, pointing up, but maybe it's off-centered, or maybe it's like to the left or to the right. We try to draw all your forces always originating or coming out from the CG. Because remember, definition of CG is at a point, there's a belief point that appears, okay, where all the weights, all the forces happen to be act on that particular point. Okay, so all the forces, try to label it at the exact location, okay, at the CG. Okay, acting through the CG. Now, so once we have it, okay, now we move on to the next part where we talk about the acceleration of the skier. Where acceleration, we are looking at the horizontal motion, okay, which is the horizontal motion, which is the forces we are involved. We are looking at, let me change color. We are looking at the applied force, the pushing force, and actually the friction, because we are looking at the acceleration, which is the horizontal motion. So the forces is the resultant force, F net. Okay, we are looking at two forces, or we are looking at two values. One is the friction. One is a 60 Newton, the applied force based on the question. Friction is 20 Newton. Okay, so if I look at if I use F net equal to MA, okay, F net will be 60 minus 20. Okay, I'll get the resultant force to be 40. And after that, if I use the formula Newton's law, F net equal to MA, I know the mass. The mass is 40 kg. Okay, the mass is 40 kg. Okay, so I will be able to find the acceleration, which is 1 meter per second squared. Just to take note for N level and O level, okay, we always like to tell students to leave the answer to 2SF, okay, for accuracy. Okay, so try to leave your answer to 2SF. Okay, if you want, you can do 3SF, but normally we accept 2 or 3 only. Okay, so now part C. Now explain why the pair of ski actually prevent the skier from sinking down. Okay, keywords we look at is actually sinking. Okay, why sinking? Okay, sinking actually give us a hint to talk about, like, we are looking at it at the force exerted on the floor, but why am I not sinking? Okay, because the ski actually has a different area as compared to maybe shoes or slippers that we are wearing. Okay, so if you look at it, we are looking at it from the perspective of pressure. So with pressure, we are looking at pressure. If you look at the formula, it will be force over area. So if I'm looking for my answer for my explanation, I will need the students to actually talk about the forces and the contact area. Okay, one thing I always tell students that if you look at the contact area for pressure, try to always include, when you talk about mention the area, try to always include the word perpendicular, because it's one of the keywords or one of the key principle when you look at pressure is we are looking at not just any area, it's actually looking at the perpendicular area. So you can go other than if you want to be safe, okay, if you want to write larger surface area, you want to be safe, you can actually write a larger perpendicular surface area. Okay, I always tell students to write perpendicular area, okay, to remind themselves the type of area that I'm interested in. And same thing is because now what happened is my area is actually bigger. The ski area is big, and because it's big, the denominator is smaller, and as a result, the pressure exerted on the object, on the snow, is actually smaller, and thus I will be able to stay on top of the snow and not sink down. Okay, because actually the large surface area has to spread out my force, spread out my weight onto the snow. So the forces per unit area, which what we call pressure, is actually much smaller. Okay, so this is what we mean by answering the question with keywords. Okay, so perpendicular area is definitely one of the keywords that we look at for pressure. Question 2 for calculation density. I would say the first few is quite standard. Okay, just need to be alert. Okay, initially it's 30 cm cube, and after that I'm 50 cm cube when I drop the solid cube inside. So straight away you will know that the solid cube actually has a volume of 20 cm cube. Why? Because the volume actually increases by 20 cm cube. Okay, after I drop it into the beaker. Now density, the mass is 26. What is the density? Remember density formula. Okay, it's mass over volume. Okay, the formula you must remember. You plug in the number, you should get an answer 1.3 gram per cm cube. For this question, right, usually the question I have from students is, do I leave my answer in kg per meter cube or gram per cm cube? If you ask me, right, I would say it is not like I have to leave every answer in SI unit yet. No. Okay, it depends, because it's in the examination context. So I will always tell students, always look at what the examiner is giving. Okay, if the examiner is asking for gram per cm cube, all right, then I will actually need to convert or need to make sure the unit has this gram per cm cube. If the marker doesn't require, in the question it doesn't state the answer has to be expressed in gram per cm cube or kg per meter cube, the marker doesn't require you. So which means any unit is okay, whether it's kg per meter cube SI units or it's a non-SI unit. Okay, gram per cm cube, both is actually acceptable. In my case, in my opinion, I would say if the marker doesn't state, just use the unit that's most convenient for you. For example, in this case, gram per cm cube, everything is in gram and per cm cube, I will just leave it. Okay, so if the question doesn't require me to convert to kg per meter cube, I will not touch. Okay, because the more conversion you have, you are more prone for, you are more open for careless mistake. Okay, so a smaller cube, Okay, smaller cube made of the same material. Important is same material. Same material, usually one of the things that I'm looking out for is actually same material. It could be same density. Okay, placed into liquid X. Okay, and of course, liquid X is given in the question already. This is liquid X and it's zinc. Okay, so now if I drop a smaller piece but of the same material, means the same density, yeah, I drop inside the same liquid. Even though it's a smaller size object, the object will still sink because it has the same density. Okay, why? Like I mentioned before, same density, it will sink. Okay, remember, density is the one that control whether you float or sink. It's not how big or how heavy you are. Heavy and big, they are factors, but more importantly is the ratio between the mass and the volume that you give rise to whether deciding factor to see whether you sink or you float is the ratio between them, or aka the density. Okay, stationary bike, okay, smaller object. Okay, okay, bicycle versus car. Okay, important thing, bicycle is small size, lighter. Car is bigger size, heavier. So we are looking at the mass of the two objects. We are comparing the mass of the two objects. And the other clue, if you talk about masses, it could be like density, it could be by forces, all these things. But how do we know it's an inertial question? Okay, usually inertial questions talk about change in motion at the beginning, either from the object is stopping, I want to change the motion to moving. That's starting or the stopping section, whereby the object is already in motion, I want to stop it. So it's more like the transition phase. So if the question does give me some clues about the transition, most likely I will tell myself to be alert for the usage of inertia. So the clue that is given to me is actually here, okay, start moving. Okay, so these two words actually tell me that there's a small transition opening here. So maybe I would like to include inertia in my answer. Okay, that's how I tell students to pick up the clues from the questions. Okay, the clue will actually tell you what topic I'm looking at. Question 3, construction site, is a straightforward, I would say it's a straightforward question. Okay, because the answers or all the values are actually given in the diagram. It's actually a difficult question for some students because the students tend to just miss out the questions or miss out the picture. Okay, they're just looking at it from maybe their own point of view, from their questions that they have solved a few days ago. So, okay, they have a preconception before they are not reading the question. Okay, so based on the question is that the distance between the pivot, which is here, okay, and the load 5,000 Newton, there's a distance of 15 meter, and the counterweight is 10,000 Newton at a distance of d meter. Okay, read carefully, yeah. So now the pivot is in the center. Okay, then after that, the first part is definition, principle of moment. Okay, I will not dwell too much. Okay, so just remember your definition. Then after that, just copy and paste, I would say. Now calculate the distance d, okay, between the pivot and the counterweight, and so that the crane will always remain balanced. First thing first is keyword balance. Balance, first thing you should know when we talk about moments, balance will be clockwise moment has to be equal to anti-clockwise moment. So this is the thing that I will need students to be alert. Okay, how do I know the two moments are equal? Because the question said they are balanced. So when you are talking about clockwise moment, so who give me the clockwise moment? Who give me the anti-clockwise? So we are going to look at it. So for the object, which is 5,000, is going downwards. Okay, so if you're going downwards, okay, the pivot is in the center. Okay, so definitely the 5,000 force will give rise to a anti-clockwise moment. Okay, our label is M5. Same thing, the 10,000 Newton on the right side, okay, which is going downwards here. Okay, it would give me a clockwise moment here. I'll leave it as M10. Okay, so I know where is who is responsible for which direction of moments. Then after that, once I have it, I will look at their respective component, force and distance. Okay, so this will be force and distance. Okay, so for the left hand side 5,000, I'm looking at M5. So the force here is actually the 5,000 force. Wrong color. Okay, so I'm looking at M5. So the force I'm looking at will be the 5,000 force. D I'm looking at is the perpendicular distance between the pivot and the force, which is your 5,000 Newton, which is your perpendicular distance, which is your 15 meter. So this will be my 15 meter. Okay, so for the left hand side, for M5, I actually have both components already, 5 and 15. Now for my clockwise moment, M10, okay, force due to moment due to my 10,000 Newton. So the force here will be F10, which is 10,000 Newton. Okay, and the D perpendicular distance here I'm looking at is between the pivot and the force, which is my D here. So it's small d. Let me change it so don't cause confusion. So it's a small d. And one thing I know is the moment M10 and M5, they are actually equal because it has to be balanced. So what I do now, I'll just equate them together in the equation, which is M5 equal to M10. Okay, so this will be my M10. It will be equate to M5. Oops, wrong color. M5. Okay, so these two moments is the same. So after that, I'll just submit the value. Okay, and I'll just let my algebra do the work. Okay, 5,000 times 15, like I mentioned, 10,000 times D. After that, use your algebra, you'll find that D will be 7.5 meter. Easily done. Okay, so take note of how I solve the question. Okay, I doesn't jump into the math straight away. I actually do a bit of preparation. Okay, I look at what are the moments, what are the clockwise and what are the moment, anti-clockwise moment. Once I identify them, I further go down, I further dissect the moments, okay, into their respective force and respective distance. So if I know M5, I want to know what are the force that cause M5, what is the perpendicular distance that causes M5. So what I do is I dissect the moments into their component before I do anything. So once I have all this, F and D, okay, once I have all my respective moments, okay, all my force, D and force and D. So what I do, I just equate them together in the equation. Okay, I would say it's not complex. Okay, it's just that the approach, the thinking behind it, the thinking process or the mathematical approach, there is a system towards it. So you just need to know what is your system and you just approach the question head on with your system. Then now the question says the length of the cable D, okay, holding the load has increases. Length of the cable looking at the load, which is where, let me take a look. Oh, here. Okay, so this is the cable here. So it has increased. So instead of just this short one, maybe now my mass is actually here. My 5,000 is actually here. Okay, a longer distance here. Okay, a longer distance now. Okay, if it's longer distance, okay, what does the question want? Okay, the question wants to look at now what happened to the moments. Okay, still the distance D. Okay, what happened to the moments, to the perpendicular distance on the other side? So if I increase my distance here, if I increase, okay, take note, does it affect my D? Does it affect my perpendicular distance on the right side? If you look at it carefully, you'll find that by increasing the distance here, it actually doesn't affect my perpendicular distance. My perpendicular distance is still 15 meter, which is here. My weight is still 5,000. It's still 5,000. Okay, my perpendicular distance and forces doesn't change. So likewise, my anti-clockwise moment M5 will not change. So if my moment doesn't change, my clockwise moment, my M10 moment due to the 10,000 Newton will also not change. So as a result, my force and my distance doesn't change. My perpendicular distance D will not change at all. It will still remain the same. Okay, and this is what I mentioned before. Okay, because I change, even though I change the length, that I don't change the anti-clockwise moment. And because I don't change the anti-clockwise moment, and because I don't change the anti-clockwise moment, there is no need to change the clockwise moment. And likewise, one step further, there is no need to change the perpendicular distance. So everything will actually remain the same. Okay. Now for section C, section C, I would say same thing. It's the same as your MCQ. I will need the students to take note of a few formulas. First and foremost, okay, pressure. Okay, pressure is F over A. That's the first formula the students must know. Don't remember the formula wrongly. Quite a few of them, they actually remember the formula wrongly. Instead of F over A, they actually remember it as force times A, FA. Okay, second formula that you need to know is mass. Whenever I give you mass, okay, be alert. I might need to change it to Newton. Okay, so it will be force times, it will be mass times gravitational field strength. And confirm. Okay, look at the question. Part A, I'm asking you for the weight of the object. Okay, so just plug in the formula, weight equal mg. You must remember the formula. Huh? First thing, I would say the booby traps I always tell students, always look out for is whenever I look at mass, okay, always make sure this guy is in kg. Or always have the habit to make sure it's in kg. Okay, so if it's in kg, yep, you're done. Put in the formula, G is 10 Newton per kg, okay, which is here. Gravitational field strength, and you get the answer 300 Newton straight away. And what is the area? Okay, area is 1.5 meters squared, given in the question. You divide, you get the pressure exerted by the box on the floor. Now, the box is given a push in 100 Newton. There is constant speed. Okay, constant speed. So, like I told the student, the moment I see constant speed, like I told you in the first question, okay, the moment I told you, the more I see constant speed, some of the clues that I need you to be alert is constant speed. It will mean the acceleration is 0 Newton. 0 Newton, what am I saying? Is 0 meter per second square. Okay, and when it's 0 meter per second square, what is the second piece of information I have is actually the net force is 0. Okay, so these are the things that you will come to my mind whenever I see constant speed. So you must be alert one. Okay, so now, sure enough, okay, what is the resultant force acting on the object? Okay, constant force, like I mentioned before, resultant force, because it's constant speed, acceleration is 0, net force will be 0. So without any doing calculation, you actually know the answer is 0 straight away. Okay, so it's I would say it's quite a standard trick or a common trick, I would say. So students, you have to be careful, okay? And so now you know that on this picture, there's a force that's not drawn, which is the friction force, okay, which is F. Okay, and likewise, if you look at the equation, it will be forward force, okay, minus friction, the usual, equal to ma. The equations that I need. Okay, and sure enough, and this is the equation that I need. Resultant force equal to force applied minus friction. And resultant force here is given 0. Okay, so if I rearrange and look at algebra, I will know that the friction encountered by the floor is actually 100 Newton. How do I know there is a friction? Okay, because the question said unpolished, or what is called rough surface. The moment you have unpolished, you have rough. These are the clues to tell you that the floor actually has friction. So you have to be alert that you actually need to go one step further to actually identify the friction. Then after the object is thrown down, pushed down to the marble surface section. Okay, marble section. Okay, then after whether there's friction or not depends on the question. And true enough, the question say lesser friction. Lesser friction doesn't mean no friction. Lesser only. Okay, so there will still be friction. Okay, lesser, but I will not know what number yet. Okay, I'm still being pushed by the same force, and same thing because there's friction, so there will still be friction here. Okay. Now, if I'm going to push at the floor, okay, so if I do F net equal to ma, forward force, this is the applied force, same thing minus friction equal to ma. Okay, now based on the question, I have a smaller friction. Okay, so I have a smaller friction, so which means my friction is actually smaller. So let me draw a bit smaller. It's a smaller friction, okay, than my applied force. So from here, I will know that definitely, okay, the FA applied force is definitely bigger than my friction. And I will know that the left-hand side, the resultant force or the net force will definitely be a positive number. Okay, so this left side will be positive. And this will mean that the right side, okay, in the equation, left side equals right side. So it will also mean that the acceleration of the object actually is positive. Okay, because why? Mass remain constant. If mass remain constant, acceleration has to be positive, which means the object will actually accelerate. Positive A means object will accelerate. Okay, and now, true enough, the question said my friction force is 10 Newton. Okay, forward force is 100 Newton. Okay, calculate the speed that I need after 1 second. Speed. Okay, so speed, I need to find, before I find speed, I need one thing, I need acceleration. Why? Because I can use I can use acceleration formula to find speed. I can use the basic formula A equal to V minus U divided by delta T. Okay, the question say 1 second. So I know this is 1 second. U, okay. Now, what's the speed initially? Initially, please take note, it's not at rest. No, don't mix up. Initially, go back to the beginning. Okay, you will know that the object mentioned is actually, initial speed is actually 2 meters per second. So for question C, okay, the initial speed I'm looking at is actually, initial speed is actually 2 meters per second. How do I know? I repeat again, because my part A and part B actually say it. Okay, the object is actually originally traveled at 2 meters per second. Okay, so my initial speed is 2 meters per second, so my U will be 2 meters per second. My A is the one that's missing. Okay, I need to find A first before I can find my velocity, which is what the question is looking for. So how do I find acceleration? Same thing, find net force first. Net force, okay, same thing. Okay, sum of forces, my FA and my friction, horizontal axis. So if you take the difference between them, you get 90, which is the resultant force. Resultant force 90, mass is 13 kg. You will know that the acceleration will be 3 meters per second squared. Okay, so if I know A is now 3 meters per second squared, I know the time is 1 second. So I will know that I will be able to find, my initial speed. I will be able to find my final speed. Okay, using the formula. Okay, A equal to V minus U divided by T delta T. Change in velocity divided by change in time. And true enough, I'm able to find my speed here. Okay, now with this, we will come to the end of this particular assessment. Okay, it's a short assessment. Okay, important thing here I am highlighting to you is that what are the clues that the question will tend to give, and what are the clues that you need to pick up. So once you pick up the clue, right, you will be able to solve, or you'll be able to know what the question is actually trying to drive you to. Which you will know what are the formulas, what are the chapters, what are the keywords that the marker actually require you to actually display. And from there, you will be able to answer, I would say you'll be able to answer the questions more effectively. Okay, so from here, this is what I mean by answering the question. Okay, so take note of the questions, take note of all the clues that is given. Okay, so with that, okay, this will come to the end. Okay, if any questions you have after reading the short video, okay, just pause and rewind back to the particular section, you rewatch again to see if you have missed out anything. And if you still have some questions or I make some mistakes that you want to highlight to me, or you need me to highlight certain section again, okay, feel free to leave your comments below, okay, or drop me an email. Okay, I will be uploading 2 other papers, okay, videos on 2 other papers. If you want to get the notification of this video, remember to subscribe to my channel, okay, and press the bell button so that you get notification whenever I upload the video. Okay, if not, okay, see you and have a nice reading. Bye-bye.